Now, obviously, this is your Sec 4 stats because cumulative frequency. Use the curve to estimate the median number of hours worked. So where is your median? Median is at 50%. There are 500 workers, you find 50%. Your median is this value, which gives me what? 40, 41, 42. So this is 41.6. So your median hours is 41.6. Again, they ask you to use the curve to estimate. Don't go and do funny things like go and find, you tell me 500, you have to find 551st and 550th and 51st. No, don't need. Okay, you just read out the graph directly when they ask you to find median. Interquartile range of the number of hours worked. So you need to find your lower and upper quartile. So your lower quartile is around here, which is 39 point. This 41, 40, so this is 39, so this is 39.6. So your lower quartile is 39.6 and your upper quartile is 44. Okay, and therefore IQR equals to 44.0 minus 39.6 to give me 4.4. Okay, it's a 2-mark question, so obviously you must show the working one. Lisa. Next, in 2017, the average number of paid hours worked in a week in Singapore was 45.1 hours. Calculate the percentage of the company's employees who work more than this average. So you draw a line at 45.1. If you draw a line at 45.1, where in the world is 45.1? It is here. Take note that what is marked there is not correct. 45.1 should be they tell you work more. So you are looking at the beyond the 415, so you have to take 500. Minus the 415 divided by your original, which is 500 times 100%. So the answer roughly will be okay. Now, there is a case to be made here that if if you take 420, I don't think the examiner will penalize you, but I think 415 is definitely the safer answer for sure. Let's move on. The company wants to reduce working hours of each of its employers by 3 hours per week. Describe what this effect, what change this will have, what effect it will have on the graph. This one very interesting. If I reduce every employee by 3 hours, how does that affect the graph? If this is a cumulative frequency graph. You shift the entire graph to the left. That's all. Nothing else will change. Okay? The cumulative, or rather the curve, would shift entirely to the left by 3 units. That's it. Because if you think about it logically, the shape will remain the same, largely. So you will just end up exactly a parallel shape, except that it's to the left. So instead of starting at 35, you just start at 32. And then the shape will be exactly the same shape. So it will be something like this. It will be exactly parallel, except that it's to the left side. Okay, that is what will happen if you minus the work hours for everybody by 3. Okay, it's like shifting. If you take A math and you learn about shifting of the graph, it's the exact same logic. A small business has 16 employees. One of the employees is selected at random. The probability that is a man working part-time is 1 out of 8. 2 employees selected at random. Both are women working full-time is 1 out of 8. Complete the table with the 16 employees. And you notice that like that is 4 marks. Looks deceptively simple, but it's 4 marks. I actually have no idea how they mark. This one I'm a little bit curious. Okay, but you start from. So you have 5 full-time workers, right? But it tells you that it only has 16 employees. So the probability that it is a man working part-time is 1 out of 8 means 2 out of 16. The probability that they are both women working full-time is also 2 out of 16. So what's the first piece of information that you know? Solve this algebraically is the easiest. So this is one of those probability questions that will end up being a quadratic equation. It will end up being a quadratic equation, and then you will find the value. Okay. You can let X be the number of men. No, let X be the number of women working full-time. Okay. Let X be the number of women working full-time. Now you cannot start with let X be the number of men working part-time because it's only 1 of 16 employees, so insufficient information. So it has to be the number of women working full-time. So that will mean X out of 16. Sorry. So P, both women and full-time, is equal to X out of 16. Agree? times x minus 1 out of 15. And this gives you 2 out of 16. Okay, so actually, if you're solving it this way, you could have it as 1 out of 8. So this is what you must derive. Your probability for both women working full-time, if you let it be x, it will give you x out of 16 for the first person times x minus 1 out of 15, because you only have 15 people left. Okay? So from here, you make denominators the same. So this one times 16, this one times 15, this one times 15, this one times 16, and this one times 15, this one times 15. Once you make denominators the same, you will realize 15x. Sorry, don't need, because I'm multiplying. What am I doing? I'm not subtracting. 10. So x times x minus 1 over. So the only thing that I need to change is this one times 15, this one times 15. Out of 15 times 60 will give me 30 out of 15 times 16. So this will give me x times x squared minus x equals to 30. X squared minus x minus 30 equals to 0. So factorize this, you will get 6 and 5. So x minus 6, x plus 5 equals to 0, x equals to 6, or x equal to 5, but you need to reject this value with -5 because obviously the number of women cannot be negative. Okay, once you get x equals to 6, you know that this is 6. Women working, sorry, not this, women working full-time is 6. Okay, and once you find that, you can find the number of men working part-time, because this is 2 out of 15, right? 2 out of 16, that means this must be 2. And therefore, you can find women working part-time, 16 minus 13 to give me 3. Done. So it is actually a quadratic equation question. Many students got, I think, 0. Okay, maybe. I don't know if you put 2. So most students will tell me this is 2. Most students will be able to get that this is 2. I don't know how many marks that will give you, to be very honest. I have no idea how many marks that Cambridge will give you for telling me that it's 2. It could be very well be 0. Alright, so many students struggle with this question because they don't realize that this is supposed to be solved quadratically. You let x be the number of women working full-time, and then you can formulate a quadratic equation from there. Alright, not the first time that they have tested quadratic using probability. If you go and look at the past O-level questions as well, especially if you have a topical set. Okay, but many students for this question don't even realize that it's supposed to be quadratic, which was the big problem. If you don't even realize, you don't even know how to get started. Alright, that's why you always tell you all, right? When in doubt, there's an unknown, let x be the unknown and then see what you can work out from there. In this case, it doesn't make sense to let the number of men working part-time be the unknown, because that can be found directly. If it's 1 man working part-time, it's 1 out of 8, obviously there are 2 such men. So there is no need to use an unknown there. So it must be the women working full-time. Alright, so not so straightforward. One of the harder questions this year.